In this video, I'll talk about a different type of regression model. It's known as the robust regression model. Well, we have been studying about the normal regression model or the ordinary least square regression model for quite some time. In this channel, you might have come across linear regression, multiple regression, different forms of multiple regressions. In all the cases, the estimation procedure is the ordinary least square, or in short, we call it as OLS. OLS is a very popular regression estimation methodology, but it has got flaws, and that's why I felt like I felt like coming up with regression models that is beyond the the normal ordinary least square regression modeling techniques. So the topic for this session is the robust regression model. I'll give you a brief introduction, and in the subsequent video I'll talk about the details of each type of robust regression model. Well, the flaws with the the OLS based regression models are there are too many assumptions. When you do a multiple regression, you will find that you will need to do a lot of diagnostic tests to ensure that the assumptions are met. What are the assumptions? To name a few, you need to take care of the normality. You should ensure that the residuals in your models are normally distributed. The residuals are uncorrelated. That is also something that you need to make sure. And there are several other assumptions. Very unlikely that you will get a data set that satisfies all the assumptions. One or the other assumption will be not satisfied with the data, and very unlikely you will find a data that satisfies all the assumptions related to multiple regressions. That is a serious problem. Of course, we have methods in which we can fine tune we can fine tune the data set to make sure that all the uh, all the assumptions are made, and we remove the problems. The issue with this kind of thing is that it takes a lot of time. Sometimes it's very difficult to find a way to get rid of these problems. Now, one thing that comes to our mind is that can we have a estimation method that itself take care of the flaws in the data? Is the estimation algorithm able to find out what are the problems and accordingly fine tune the algorithm to model even with the flaws? I mean, the flaws are part of the algorithm, or the algorithm takes care of the flaw automatically without us having to interfere. So well, that's where the robust regression uh, plays a good role or comes to our rescue. This kind of a regression do the adjustment, uh, and it takes into account the flaws in the dataset. If your the errors are not normally distributed or errors are correlated, the estimation happens in this kind of a regression in such a way that these problems are taken care of inside the algorithm. You don't have to do anything else extra to deal with these problems. The estimation algorithm will take care of these problems. Okay, so it will account for these problems. Okay, so you could get flaws in the form of biased standard errors or the correlated residuals, non-normality of the error, and so on. Okay, So robust regression is primarily used in cases where there is issue with the data set, or the data set is something that do not fit into a lot of assumptions in the multiple regression. If you have one or two assumptions failing, uh, then it's okay. You can correct the data set, or you can do something about it. But if there are so many assumptions failing, and it's difficult finding out ways to deal with these problems, we go in for robust regression, and that is a preferred way of doing the analysis. So in the subsequent video, I'll talk about the different forms of robust regression, and also give you example in which I'll explain like how to do the estimation in SAS, so that you can do it yourself. Okay, so see you in the next video.